In this question, we have an arithmetic sequence. This means that we add a number on each time to get the next number or term. So if we look at our numbers, if we go from 11 to 14, we're adding 3. 14 to 17, we're adding 3. 17 to 20, we're adding 3. So that's the rule for this sequence, add 3. So the next two terms, if we start with 20 and add 3, we get 23, add 3 again, and we get 26. Moving on to part B, we're now being asked to find the nth term of the sequence. So this is going to be a formula with the letter n in it. The first thing we do is look at the difference between each pair of terms. So 11 to 14, there's a difference of 3. 14 to 17 is 3, and 17 to 20 is 3. And if this difference number is the same every time, it means in the formula for the nth term, we will have that number 3 multiplied by n every time, and then we will add or subtract a number to make the answer correct. What we mustn't do when we get a difference value of 3 is just write n add 3 as the nth term. This will not be correct. It's always the difference 3 multiplied by n. So to find this number that is added or subtracted, one of the ways we can do this is to look at our terms in the sequence. There's 4 of them. Write down the n numbers, 1, 2, 3, 4 for the 4 terms. And then we can work out 3n for each of those n numbers. So 3 multiplied by 1 is 3, 3 multiplied by 2, 6, 3 multiplied by 3 is 9, and 3 multiplied by 4 is 12. We now write down our sequence numbers next to the 3n numbers. So we've got 11, 14, 17, and 20. And now, if we look at these numbers, we can either add or take away a number to make the 3n number equal the sequence number. So if we look at the 3 and 11, we would add 8. If we look at the 6 going to 14, we would add 8. If we look at the 9 going to 17, we would add 8. And if we go from 12 to 20, we would add 8. So add 8 must go with the 3n. So the nth term for this sequence is 3n add 8. Moving on to part C, which of these numbers are in the sequence? Now that we know the nth term is 3n add 8, we use this. So we write 3n add 8, and we find out if it's possible that that might equal the 501. So we have to find n. So we take 8 off both sides of the equation. So we get 3n, and 501 take away 8 gives us 493. And then to find the value of n, we have to divide by 3 to get the n on its own. So it's 493 divided by 3, which is 164.3. And because this is not a whole number, the term 501 cannot be in this sequence because the n value has to be a whole number of terms. So we now take our nth term again, 3n add 8, and we see if it could equal 502. And we repeat the process, take 8 off both sides, 3n would equal 494, and then divide by 3. So 494 divided by 3, and that would give us a value of 164.7. So that's not a whole number. So we're guessing that 503 will be the answer, but we need to be sure. So the nth term is 3n add 8. Can that equal 503? Take the 8 off both sides, so 3n will equal 495. Divide by 3, so the n value is 495 divided by 3, which comes out as a nice whole number, 165. So because that is a whole number, then that number 503 will be in our sequence. We were asked to circle the correct answer, so it's 503, and if we want to make it absolutely clear, we can write it at the end, answer 503.